Welcome to the final lesson in Chapter 1 about reasoning. This lesson is about problem solving. How do we find area and perimeter of certain quadrilaterals? All right, let's start with some vocabulary. Formula is an equation that shows how certain quantities are related. We should be familiar with formulas, a lot of them, but here is just the formal definition. Perimeter is the distance around a figure. There really is no specific formula, or I don't want you to stress too much about remembering a specific formula. You just need to remember that perimeter is the distance around, and we calculate that by adding the length of all the sides together. Final vocab is area. It's the number of square units needed to cover a figure's surface. So the space inside the figure. So we have some formulas here for a rectangle. This also applies to a square. Perimeter is twice the length plus twice the width. That comes from adding two lengths together plus two widths together. So as long as you're adding all four sides together for the perimeter, you don't have to memorize that formula. For area, it's length times width. For something, a slanted quadrilateral like this, you want to make sure that you are using, you can't use the length and height. Notice that the formula is similar to length and width, but you can't use those terms because you're not using the side of the shape here. You need to use the actual height. So the base times the height really is the same thing over here, base times the height. And that's why some people get rid of this formula. They don't even use it, length times width. They like to think of base times height because it can be applied to more specific situations. Let's go ahead and take a look at a few practice problems for perimeter and area. We do have these formulas. This formula for perimeter really specifically applies because they are both rectangles. So I'm just going to go ahead and I'll do the perimeter first for this first problem using the side lengths of 4 and 12. It doesn't really matter which one you put where as far as length and width, but normally we do consider the long side to be the length and the shorter side to be the width. Perimeter of that rectangle is 32 feet. Area of that rectangle is 48 feet squared. So one thing I want to talk about really quickly before I show you the answers to this last or second set of problems there is the decimals are really why I choose to use parentheses to show my multiplication, because when you use the dot for the multiplication and the dot for the decimal, a lot of the times those two symbols get mixed up as to whether or not you're multiplying or if it is a decimal point for the number. So I just try to use parentheses most of the time, but especially whenever I'm using decimals to multiply. Since this second shape here is a parallelogram, we need to switch our formulas for area to be the base times height, because again, the height of this shape is actually 8 meters off of the ground, though the slant height, as it's called, is 10 meters. That is longer than the 8 that it actually takes to get to the top of the parallelogram. So when we are finding the area inside, this 10 is not helpful. Instead, we're using the 8 and the 19. Now, I did not mention the perimeter formula because there really is no formula for perimeter when it is not a rectangle. Technically a parallelogram, we can use that same formula because the two opposite sides are congruent. They are the same, but just to show you, remind you that it is just the distance around the object. So it's gonna be the 19, let me write P equals here. Perimeter equals 19 plus this 10, plus over here, because it's a parallelogram, will also be 19. And then down this slanted side will be 10. So the number that becomes useless for us with perimeter is 8. So the 8 is on the inside of the parallelogram, so it does not show up in the perimeter formula. Much like with the area formula, the 10 isn't helpful. So we really have to be careful with our parallelograms. Sometimes you're gonna end up with problems about area and perimeter that just don't have a picture. And when that becomes the case, the easiest thing for you to do first is to draw a picture. So in example 3, these two problems are dealing with area, and it looks like the first one is area of a rectangle, so I went ahead and sketched out a rectangle. And then number 2 says finding the height of a parallelogram, so I went ahead and sketched out a parallelogram. Once you have your sketches completed, we can actually start to label your picture with the information in the problem. It says find the area, so that tells me right now I'm going to need area equals the length times the width formula. And it says find the area with a length of 14 and a height of 10. So we can label our height with the 10s, and then it says the lengths are 14, so I can go ahead and label those as 14. I will add that the label is inches once we get to the actual answer. So I just have to multiply these two numbers together. The length is 14, the width is 10, so we're going to make that 140 inches squared since we're finding area. The parallelogram problem is a little bit different because it says find the height. So the height of a parallelogram, remember, gets drawn inside, and it says we're finding the height, so that means I don't know what it is, so that's going to be represented by a variable. It does give me the area and the base. So using the formula for area of base times height, I can substitute in the 45 for the area and the 5 for the base because that's the information that's given to me. All I have to do is find the height. So we're going to use our algebra skills here and undo that multiplication by dividing both sides by 5 to get the h by itself to represent that the height is 9 centimeters. And again, that label is coming from the problem. So the height of the parallelogram is 9 centimeters. If we attempt those problems without a picture, then it's really just recognizing and labeling using symbols what information is given to you. You are finding the area, so I wrote down the area formula, and I've highlighted or underlined, recognize the information that's given. The length of 14, so L equals 14, and the height of 10 inches, H equals 10. Now this is where it could get a little confusing with the fact that, well, the formula has an L and a W, but I was given an L and an H. And this is just recognizing that when it comes to the area of a rectangle, it doesn't really matter. I don't want you to get bogged down by those labels as to which side is a length or width or height. If they're giving you those two side dimensions, then those are the two sides that get multiplied. You work through the same thing with the second problem, again, just using the formula and the information that's given to you. You're just doing it without a picture. Highlight, underline, those sort of helpful techniques in reading the problem and recognizing what information is important. Here are two challenge problems for you. I'll read them and then I'll provide the answers on the next screen. Just go ahead and pause the video and give them a go on your own. It says to find the length of a rectangle whose width is 13 inches and whose perimeter is 60 inches. So think about the information that's given. Obviously, I suggest that you draw a picture. Number 4 is very similar to the last one where it says find the height of a parallelogram. This time they're giving the area is 234 square feet and the base is 9 feet. So still very similar to the last parallelogram problem that we had, but number 3 is definitely a little bit different using the formula for perimeter this time. The final sort of example from this video is going to be the area and perimeter of irregular shapes. It's very true that shapes are not always the same size and not always perfect rectangles or other shapes. So we have to use the information that's given to us and what we know to help find missing pieces, to help us find the area and perimeter of these irregular shapes. So looking at this particular example, this is very clearly labeled 6 and 3, 4, and 4. What's not labeled is this line here and this line over here. A common mistake when finding something like perimeter is students only add the numbers that they see. So they would add the 6, 3, 4, and 4, but that would not be enough to actually represent this entire perimeter because we have this missing side and this missing side. So in order to find this missing side over here, we can look directly across from it, down from it, and there's this piece right here would be 4, and this one is 3. So the 4 plus 3 together, or 3 plus 4 when it looks like that, that's going to be 7 inches on this side over here. On this missing vertical piece, this whole side is 6, and we know over here that this is 4. So it's like imagining, let me see if I can do it. Nope. Imagining that we're taking this purple line and we're floating it across over here. And so in order to figure out what's down below, we just have to do 6 minus 4. And actually, let me put that here. 6 minus 4, that's going to give us 2 inches. And so this is all work for the perimeter, so I'm gonna go ahead and add those numbers together. The perimeter is 26 inches. Let's go ahead and do the area. When we're doing the area, we split the shape into 2 shapes that you know the formula of, and making sure that you know the length and width or whatever elements you need in order to complete the formula. So this would be a 4 by 4 square, and I can call it a square because they are the same side length. So I'm going to do 4 times 4, and so this is going to be 16 inches squared, so that's the area of that piece there. This rectangle is a 6 by 3, so it's going to be 6 times 3 to equal 18 inches squared. And so in order to get my total area, all I have to do is add the 18 plus 16 together to get 34 inches squared. For this next example, same goal, finding the area and perimeter of the figure. I want you to understand that there are lots of options for the way that you chop these irregular shapes into shapes that you are familiar with. When they're just a bunch of boxes, then you have squares, rectangles that you could be chopping things into. I would not suggest like voluntarily creating a triangle because it's a rather simple formula for area, but it's not something that is easy to always find all the pieces of with the base and height. So my suggestion would be to chop there to get 2 smaller triangles, and 2 smaller squares, and then 1 bigger rectangle. You also have the option, though ignoring those purple lines, to create that rectangle, this one, and then this one here in the middle. However, in tracing that out, notice that when I just made this rectangle here, we don't actually know this length here, because this, even though the 11 is right there, the 11 represents the whole thing. So you want to make sure that you would be doing some math to actually figure out what this length of this middle rectangle is. You can find it, it's just going to take some extra steps. Okay, so that's just something to consider whenever you're deciding how to separate your irregular shape into shapes that you know. Let's go ahead and get the answer for this one. So the work for the area is right here. The 9 is coming from this 3 times 3 space and this 3 times 3 space to give us 9. And then the 33 is coming from this 3 times this whole 11 to give us 33. So that's where the area is being calculated and adding those up. For the perimeter looks like everything can be, we know all of the values of every side except for this one right here. And you can see that that value is going to be a 5 from the fact that this whole side is 11. We take away the 3 and the 3. So from, let me just extend that arrow here. This is really 11 minus 6 from that 3 and that 3, taking that away to get that 5 there. And adding all those numbers together to get a perimeter of 40. Paying attention to the labels again, area is going to be the centimeters squared and perimeter will just be the units of centimeters. I want you to go ahead and try this one on your own. Just remember that when I do show you my answer on the next, section here, just realize that your work may be different, but we want to make sure that we're getting the same final answer. And if we're not, you're really going to want to pause the video and compare your work to my work to make sure you're understanding where some mistakes might have happened. All right, same thing for this last problem that is on the back of your notes. Go ahead and give it a go on your own. Realize that there are lots of options here for chopping this one. I would definitely suggest you start by chopping off that triangle up top. This 4 is the height of the triangle. I think there's enough information given on your other lengths to figure out all of your other pieces. But go ahead and let's just focus on the area for this one. Let's do area only, please. Final answer for area only is 166 units squared. That concludes this first section of notes for Lesson 6 for problem solving, which does answer the lesson essential question about how do we find area and perimeter of certain quadrilaterals. We use formulas to relate the dimensions of the shapes.